Life begins at NIIT. That is where I really wanna be. NIIT.
Hello everyone. Welcome to NIIT webinar. This is Arunava Sarkar. Currently I'm working with NIIT as a technical trainer. So agenda for the day is to talk about these technologies that you see in front of you. So we'll initially start with the web application overview, and we'll talk about the HTTP protocol. We'll talk about the various front-end technology which is used. Then we'll see a program, how a web application is built. In the second section of the webinar, we'll talk about cloud, how cloud works, what is Amazon Web Services, how does it work, what is Amazon S3, and how can you deploy a static website over Amazon S3. So let's move to the topic. So the first section, if you see, is talking about a 3-layer architecture for web applications. So it's not only about web applications. All kinds of applications generally has 3 main tiers where the entire flow or functionality of the application is divided. So you have a user at the front end. So this is the user who's trying to interact with an application. So he interacts with the UI or user interface. This user interface can be built from different languages, but for a web application, it's generally built from 3 core technologies. One is HTML, one is CSS, and one is JavaScript. After this user has interacted with these different components, these components will then interact with the various back-end logic or your business logic architecture. So every application that we build always have a backend. This backend actually talks about the business logic of your application. The business logic basically represents what the application is built for. What is the purpose of the application? The functionality of the application. Okay, suppose you are building an banking application, so all the calculation for interests and things like that, these are all covered within the backend logic. But for this backend logic to work, you need access to your data. So the data is accessed to the data model or the 3rd layer of your application. So this is where your data exists. The data is then sent from the data access layer onto the business logic, and this business logic generates the UI which is sent back to the client. So this is how your 3-tier application works. So the user interacting with the front end, which is built from HTML, CSS, JavaScript, interacts with the business logic, which is the middle tier, and then this layer talks to the backend database, or we call it a data access layer. This is what a 3-tier architecture is built for. So in web technologies, the first thing that we need to understand is how a request is sent. So what actually happens when you send a request is like you have a browser. This browser will send a request to a server. The server will receive the request on a specific port. Generally, if you are using HTTP, the request will be sent to port 80. Means your client's browser, maybe you are using a Google Chrome or Firefox or Mozilla Firefox or Google Chrome or Maxtron browser or Safari or anything else. These all send a request to the server. So this server will listen to this request on port 80 if it is an HTTP request. But the problem with HTTP is that it's a plain text request. So the data is not encrypted at all. So if you wish to encrypt the data so that someone in the middle who tries to get the data won't be able to understand what the meaning of the data is. We use HTTP along with SSL, which builds your HTTPS request. With this HTTPS request, the data is encrypted, and the port is which is generally used is 443. The port that is generally used for this kind of request is 443. So what actually happens? If you see, this is a request header. So whenever a request is sent, it is sent using a specific header. Header contains all the information that is needed to generate the request. One of the things that exists inside it is the method. The method tells you the request that is sent has which kind of parameters attached to it. You can have get request, you can have post request, you can have put request, you can have delete request. All of these requests have their own features and functionalities. In most cases, we generally use get and post. Get is something that is sent when you want to send your data, which is visible to everyone, and it's actually attached to the query string. The post request generally goes when you want to hide your data and you don't want people to see what you are sending. So for that, post is used. So these two methods have their own specifications where they want to be implemented. So based on that, you have to select which method will be used. Once the request is received on the server will respond with an HTTP response item. So this HTTP response contains a lot of information. Among them, one of the information that is very important to understand is the content type. So your browser sent a request. The request is received by the server is now responding. The server is responding saying that I'm sending you the data, which is in a specific type. Okay, this type in web technologies is called MIME type, MIME. This basically represents a specific format which the data can be decoded. So your data which is sent from the server will have a specific content type which will be used by the browser to identify what the content attached to it is, so that it can understand and process. Here you can see it is written as text/html. So you may use it like text/css, text/javascript. You can have like text/application/xml. You can have application/json. You can have different forms. Whatever form is, the browser will try to understand and will try to show it in the way how it is shown. Okay. So if you are sending an PNG image, the content type here will change into image/PNG. Okay. And the last very important piece of information that you have here is the status output. So here the status basically means once this request is sent, what happened to the request and what is the response or output from it. Means, is the request properly served? Is there any error? Is the resource where it was sent, is it properly found? All of these are actually mentioned using the status queue. So this status, when it is 200, we call it a success request. Means the request that was sent was properly processed by the system and it is now properly available to you. If this number is somewhere around like 404, we know about a very popular error form 404, which represents that the request resource is missing. That means whichever request we tried to send to a specific item, that item was missing from the server, so it gave us a 404 error. You may get a 500 error. This represents a scenario where the resource inside the server could not process properly and generated an error. So this way your HTTP requests are done. So for web technologies, HTTP is a very important resource to work with. Okay. So the first language that we have in our front-end design, because we are talking about front-end today, is HTML. HTML stands for Hypertext Markup Language. It's basically a language used to build the UI, front-end UI for for the applications that we build. So it's built based on something called tags. Okay, tags represents something like this. So this is a tag. It has a starting portion. It also has a ending portion. So it starts, it ends, and it contains a content part. So what actually happens is that your browser knows the meaning of each and every tag. So here we have a tag that is called a p tag. P tag is used for putting paragraphs. So your system knows how this P works and what is the meaning of the P and how it should be portrayed inside the browser. So for you as a normal user, this is a normal text. For the browser, it's something that can be generated as a graphical output. Every tag is actually enclosed inside the Angular braces. Okay, so and every tag will have some attributes. So by default, the tags have their own functionality. If you want to customize these functionalities, or if you want to add some features or functionalities along with that specific thing, you can use an attribute for that. There are various attributes for doing various specific things. So all of these tags put together builds your DOM structure. So DOM stands for document object model. If when we'll say in the next slide that a web like page or a HTML file is actually an hierarchical structure. So it has multiple layers inside it where various components are built, which we can identify using something called an ID. So we can individually identify one item with the attribute called ID. So it is actually a tree kind of structure where you have a root at the top and you have various leaves at the bottom. You can go through them, we can traverse through them and reach to a specific element on which we can do certain things. So like if you have a button, you want to add something to it, you can use a proper structure hierarchy and go through it to find out the item that you have. For that, the DOM structure is used. Okay, so if you see, this is a basic layout of a web page. Here what happens is that the top tag that we have is specifically saying that it's an HTML5 document. So HTML was a very like it was built long time back. Okay, so like eventually what happened, it growed and it added more and more features into it. The current version that we have is HTML5, and this version, if you want to tell the browser that this is a HTML5 document, you need to mention it at the top one, the doc type, which represents that it's a HTML5 document. Second thing, if you see here, as I told you previously, that it's a hierarchical structure. So there is always a root at the top. So this is your root. This entire thing is your root. So everything comes under it. So every tag has a starting part, it has a closing part. Everything is enclosed inside it. Okay. So in my HTML document, you can see there are basic two parts. One is the head, one is the body. The head is like a human head. So whenever we want to do certain thing, we actually process the head first, and then we do things with the body, isn't it? So the head contains mostly the pre-processing part, which the system should process before it starts doing certain things with the components. Here you can see that we have two different tag sets. One is called style, one is called script. So HTML itself is only built to make the layout of the page. It's not built to add everything. So if it's like you build a wall which doesn't have any colors inside it, it doesn't have a window or it cannot do anything. Okay, so it's just a plain wall. So HTML is something that can make that plain wall. Okay, so if you wish to add functionalities, you need to add inside it something called a CSS or something called a JavaScript. So CSS will be used to add the graphics, and JavaScript will be used to add the functionality. On what? On this structure that we have. So this structure that you see here, this structure represents our DOM structure. So this is the model how my browser will try to understand and read the thing. Okay. So what happens? Various tags, like for the example, this title tag has its own meaning, which will be used by the browser to do a specific thing.
So guys, as you can see here, so we have the selector A, which is basically used to select the item from your DOM structure. So whatever elements that you have inside your DOM structure can be selected using the specific element. So here we can have an element called A. This element gets selected using the tag, this tag, and you have certain properties. You have certain properties here with a specific value assigned to it. These values can be any specific value, but it depends on the element that you have selected, which kind of property will be implemented. Now, instead of using tags, you can use a class selector also to do that. So what in this case, suppose if you can see here, the class of Adam of admin is used to represent the Adam hyperlink. So you can see here we used a dot notation to specify this element, which is an Adam, and which has a class of admin. So the property of color red will make this text a red color. In the same way, with an ID selector, you can specify only one element. So IDs cannot belong to multiple elements. So if you have one A tag and another A tag, these both can be part of the same class, but they both cannot be part of the same ID. Okay, so IDs are unique, classes are groups, and tags are all of around. Okay, so in this way, what you do actually from the DOM structure, you select elements and you provide them with the properties along with their value. The implementation of CSS can be done using 3 different ways. One is using inline CSS, one is through internal CSS, one is through external CSS. If you think about the functionality, internal CSS basically represents a scenario where you put down your CSS property inside a style attribute inside your element. So when I'm writing down here an A tag, I can add a style attribute inside it and put the property for CSS inside it. It will work fine. The benefit is that it will be having the highest priority and it will be implemented on this element. Second one is the internal CSS. It's based on the page. So you get a script tag. Inside this script tag, you can put all your CSS content, and this CSS content will be available for the entire page. But the problem with this thing is that you need to mention this for each and every page. If multiple pages inside your web page or your web application has the same kind of design, it's a very hectic stuff to do. So for that reason, you have external CSS where you can take your content inside a CSS file and then use this CSS file to be imported inside your page. So if you import it inside like 20 pages, all the 20 pages will get the same properties. So you can implement that in a like one-to-many basis. So these are the 3 ways you can implement CSS. The next most important component, if you think of, is the JavaScript. JavaScript represents a scripting language which exists inside the browser. So the user simply takes in this script to implement some kind of functionality in this client side. This is a client-side scripting language. That means that this script gets transferred into the user's browser. So when your browser opens a website, the HTML, CSS, and JavaScript gets downloaded into the browser, and it starts doing whatever it has to be. HTML will be building the design or layout, the CSS will be designing the graphics, and this JavaScript will be building the functionality. Okay. So JavaScript is case-sensitive language. So that means whatever you write inside JavaScript has to be written in the proper case. So capital letter will be capital letter, small letter will be small letter. You cannot join them together to make something new. It won't work. JavaScript comes from a scripting standard called ECMA. ECMA stands for European Computer Manufacturers Association script. So JavaScript is built from a script called ECMA script, ECMA script. this is the core behind the JavaScript language. This is not the only thing that is behind JavaScript. ECM is used in other languages also. Okay, like you can think of like CoffeeScript, TypeScript. These are all based on this thing. Okay, so the implementation of JavaScript can be done in these three ways, where you have an inline JavaScript in which you write down your JavaScript functionality within a specific element tag. Means every element here, like an A tag, an anchor tag, will have a lot of events associated with it. Events in the sense, you can click on it, you can drag it, you can put your mouse over it, you can write something inside it. All of these things are basically events. So JavaScript lets you do what? You can take some events that exist for a specific element, and then you can bind a certain functionality inside that item. The next thing that you can do is the internal CSS, internal JavaScript. In this, what happens? You put all your JavaScript scripts or programs inside a script tag, which will be available to the entire page. So one web page will be able to take its components from this one script tag, and you can put a lot of different functionalities inside different blocks. We call them functions, and these blocks can later be accessed by various elements associated with their specific events. So this way you can implement a way of JavaScript which is centralized for our central pages. The third way is by implementing it through a script file. A script file is simply a .js file which holds all the functions that you need to have, which can be distributed among a set of HTML documents like this way. So the script tag here imported the script file, and now this function show is available to the page. So this same script can be implemented in 20 different pages, and all of them will have access to the same function. So if you need a centralized system where you can write down all your scripts and it will be available to everyone, you need to go through this one. Okay, so these are the various implementations, how it is done. Now there are two more things I need to talk about little. Is one thing is called Bootstrap and one is called jQuery. So what actually happens is that Bootstrap is basically a JavaScript and CSS library. Actually it's a CSS library, but JavaScript is also used inside it to do certain properties. So what Bootstrap does, it provides you a more robust and easy to implement way of writing scripts, CSS scripts inside your web page. Okay, so it gives you the option to build a more robust one. jQuery is something like a library for JavaScript in which they have added a lot of functionalities which you don't have to always think about. Your system, your jQuery will be imported into the system, and it will take care of a lot of functionalities that you need to implement, not with the plain JavaScript, with some pre-built library functions inside the jQuery library. Okay, these are open source, free to use. You can use them, download them, do whatever you like. The next thing we're talking about is a web page. So we are dealing with a web page. So this web page that you see here is basically our sample page where we want to show how we can deploy a static website onto our S3 environment. Okay, so here you can see the same structure of document exists. Here in the body part, you have some scripts written for the body. Here you have a certain property for a specific element that has a background class of BGIMG, and it's just doing what? It's just putting a background image into it. Okay, there are some positions, font family, font styles, font size, some locations, positions, like margins, and all of these are implemented on these specific elements, where you have certain classes with certain values. These values are accessed here, and the properties are implemented based on these specific elements. So as an output for this one, you get somewhat like something like this. So you get an output something like this. In this output, you can see that we have a background image, we have some text in the front, and this is very simple, like one-page application which we want to deploy in our S3 cloud. Okay. So coming to the next item. So now we'll talk about cloud computing. So initially what used to happen was like companies used to have their in-premise data centers in which they bought a lot of servers, they deployed everything, and they had a lot of capital expenditure to build the entire architecture. They needed skilled employees who know how to manage these things. You need to have like your own security for that devices. You need to provide 24/7 electricity. You need to have like technicians. You need to have a lot of operational cost as well as upfront capital expenditure. So as per OPEX and CAPEX, the in-premise environment was not that much of a good idea. The benefit was that like you have control over your environment totally. Okay, it's your premise components, you have the full control over it. But the problem is that you bought something for a certain event or for a certain scenario. After that event is gone, you don't have the requirement for that specific application for a longer period of time. So it's just a waste of resources. Okay, so the cloud computing concept came out saying that if we can rent servers to people who need it for a specific amount of time, they will just pay us for the usage. In this way, the implementation or the implementation of a business concept will be much easier for the companies to deploy rather than buying a service. So what is actually happening is that I need to build a server. I need to wait for the company to provide me with the server. I need to go through the entire process of designing, deployment, everything. Then it will take maybe 2-3 months to deploy the entire thing. Then I can see what is going on in the market. But in this scenario with cloud computing, I can do the same thing in minutes. I can deploy a maybe 128 core, 500 GB RAM server in minutes for a certain processing that I want to do. So it gives you the flexibility that you need on a pay-per-use basis. That's the main thing. You don't have to pay for the hardware instantly. You're just paying for the use that you're using. Okay. Anytime you want to close it, you can just close it. This is the core reason behind implementing cloud computing. Okay. So if you see this architecture here, you have in-premise architecture and you have cloud architecture. In in-premise architecture, you can see there are a lot of components that are needed to manage your environment. And here with the cloud architecture, you simply do not like hold everything with you. You actually outsource most of the things that you need to do. Most of the things such as maintaining the hardware, maintaining the IT professionals, the maintenance of the devices, training for the devices, security, compliances, everything are actually outsourced to the service provider. Okay. Now, how service provider handles this thing? These service providers handle this thing by a technology called virtualization. Virtualization is basically a mechanism that lets you pull down multiple big like resource pools. Here my resource pools are like compute services or like RAMs, like storage, CPU in a big bulk, and then break it down into smaller pieces to be given to the client. So whenever a client needs a service, he'll just go through and ask for a certain amount of RAM and CPU, and it will be given to him. Now this way of like providing pieces of like a big set of resources is done through something called hypervisors. Hypervisors are basically the backbone behind virtualization. So virtualization is basically a layer of abstraction that is put in front of the physical hardware so that people cannot understand what is going on in the background, but whatever resources they need, they can just get it, and they can be paid they can be like charged based on that resources that they're using. So if someone is not using a resource, this resource can be used by someone else. So it gives the service provider more flexibility. If I rent a server, I'm not using it, but that resource can be used by someone else. Okay, so it gives the service provider a lot of flexibility. It gives me as a client also a lot of flexibility. So for this entire thing, you have virtualization in the back. Virtualization is basically resourcing a big pool of resources and then breaking them into smaller pieces as per the requirement of the client. Okay, so this kind of resource pooling gives you with the service called infrastructure as a service. Infrastructure as a service. Okay, it simply means that you take in the physical servers which are actually located in a place called a data center in a client environment. This data center will hold all the physical hardware for the service provider. It will maintain all the network services. It will maintain all the storage, compute, security, everything. You will be given a virtual machine, a VM, which is just like a physical machine for you, where you can install your own operating system. You can do whatever you like. Okay. The benefit with this architecture of infrastructure as a service is that you as a client, you don't have to think about the physical devices. My RAM got broken, my hard disk got broken, something damaged. You don't have to think about them. Okay, you just have to think about, okay, my resources available to me, what kind of resource I need. If I want to scale up, I want to scale down, I want to increase it, I want to have a like vertical scaling, I want to have a horizontal scaling, do whatever you like. It's flexible for you to do. That is called an infrastructure as a service. So you are given the base hardware on which you can build your virtual infrastructure. On that, if you are provided with the software, the platform in which you can build your own software. So you are given with the OS bundled with all the patches, all these services, everything installed in it. That will be called a platform as a service. Here, you as a user don't have to think about the operating system, what is running, what is things like that. So, okay, so as per software as a service is concerned, in this service, you actually get the hosted application in front of you as a user. You just provide the data that is needed to be added into the system. You don't have to think about the operating system. You don't have to think about the underlying physical hardware or anything else when you run this service. For example, if you think about Google Docs, in Google Docs, you as a user doesn't have to think about how the data gets stored inside the data store or how this entire infrastructure is built. You don't have to think about how this software is built, how Google Docs stores this data, nothing else. You just have to think about the data that you are storing, and Google will charge you based on that data that you are storing. So deployment for clouds can be done in these three models. First one is the private cloud. In this one, what happens? The entire infrastructure is built in premise in your own place. So you have control over the security of the devices, and the entire maintenance and things will be done by you with your own team of like IT professionals. So here, this is the old traditional way of maintaining the IT infrastructure. So it's like a private cloud where you have everything in your own control. In a public cloud, what happens? You have service providers who provide you with the services. You as a client just take these services, pay for them. You don't have control over anything. You just go through the service, pay for the use that you do. You don't have really no control over it. So companies don't like this kind of an architecture. So companies generally use something called a hybrid cloud. In a hybrid cloud, what happens? Some of the services are run on the cloud. Some of the services are run in premises. So maybe very critical informations are stored in the in-premise data center, and some public components which are not that much important for the company can be stored inside the public cloud to reduce the expenditure for the data. So these are the three models that can be implemented in a cloud architecture. So the cloud service providers, if you think of, these are the three, like these are some of the main service providers that you have. So among them all, AWS stands out because AWS has the biggest infrastructure for cloud service providers, and because actually Amazon has around like 6 times more the compute power for all the other companies put together. So it stands out in that way. So this chart also shows you the market share for Amazon, and you can see it's almost like 33 to 35% for the entire market share till the second quarter of 2019. Because it provides a lot of different services, because Amazon is not only infrastructure service provider, it provides you with exact applications, it provides you with exact platforms, it's not only like infrastructure service provider. So Amazon is basically the parent company for Amazon Web Services, AWS. AWS was initially built in 2002, and currently it has more than 100 services. So every year there is an event called reInvent, in which they launch new services. So Amazon is the market leader in cloud services at this point of time. So you can see the infrastructure is most important thing in cloud service provider architecture, in which the infrastructure is initially built with the data centers. So the data centers are basically places where you put your physical servers. You stack everything together. You have security. You have like technicians to manage everything. Then these data centers are put together to make your availability zones. Availability zones are basically like portions of your region. The portions of a region is built from multiple data centers. So the data gets actually distributed among these different data centers to provide you with a higher like availability of data. So these availability zones are put together to make a region. At this point of time, there are 69 availability zones, but these numbers change because every year Amazon releases or creates new availability zones to improve their global presence. So at this point of time, there are 22 regions, but it's increasing every year. There's something called an edge location. This is basically a place where we can call it like a point of presence for Amazon services. So suppose if there is a client in a remote part of the world where you do not have services exact regions, so in that case you can have some like edge locations over there, so that the client doesn't have to get the data from a longer distance. So these points will be like having a temporary cache copy of the data, so which can reduce the speed in which the user is receiving the information from the service provider. So you can go to this website, https like infrastructure.aws. Here you can see all the like locations where these infrastructure is built and get information about it. So this is an old image, but it contains some of the information about the various locations with the regions and availability zones. Okay, so the numbers that you see inside the orange circles are basically availability zones, so how they are built, and the green ones are basically the new ones which are coming up soon. So these are the core services that Amazon services AWS provides. Now, if you think about core services, you basically think about these services: compute, storage, database, networking, and administration and security. So if you think the compute is the base service that you think about, it's like your VM or your computer, in which you provide a certain number of RAM, a certain number of CPU, and your system runs fine. So EC2 stands for Elastic Compute Cloud, is basically a service that gives you the option to create VMs of any specific size or whichever you like, and then you can use these AMIs. AMI stands for Amazon Machine Images. These images can be then deployed into these EC2 instances to build your environment that you like. These AMIs can be for Windows, Linux, you think of that is available. Okay. Second one is the storage and content delivery. Basically, it tells you that how you can store your data on a cloud architecture. So S3 stands for Simple Storage Services. S3 is the one that we'll be looking today in a lab practical. EBS, like it's a block storage, file system like Elastic File System, EFS. These are all ways how you can store data inside your cloud infrastructure. Databases, here you can see you have relational database services. So you have various like industry standard databases like MySQL, MS SQL. These are all like relational databases available. If you are thinking about NoSQL databases, you have DynamoDB, you have Redshift for like analytics services. So all kinds of database services are provided to you from Amazon. Networking services is very important. VPC stands for Virtual Private Cloud. It's basically a separate cloud within the Amazon infrastructure. So it gives you the option to build a private portion of your network. So the data will not be available to the outer world actually. EBL actually represents elastic load balancing. It's basically a way to balance your request that is going to the server. The next thing is administration and security. In this, basically, we talk about like various kinds of roles and user access management, how we can protect our like resources from being accessed from the user. If the user is not a legitimate user, we should not be allowing him to access. These are all taken care in this section of the item. So you can see on the left hand side, these are the various requirements for the cloud services. And on the right hand side, you can see all the Amazon services which are doing the specific task which is being mentioned. So S3 basically is a storage system. So files, actually data can be stored in 3 ways. Okay, the first one is file storage, second one is block storage, third one is object storage. So the S3 uses object storage, basically a way to gather a lot of information together, providing some information about that specific set of information, which are called like metadata. This information can then be used inside the system to store the data in a proper place. So it can be stored without a proper hierarchy. So it can be stored anywhere actually in your storage. So the way how S3 stores information is basically like buckets. Think like your bucket like a directory. In this directory, it's unique for individual users. So when I'm building a bucket, that is unique for me. So no one else can have the same bucket with the same name. So it's just a globally unique name, and these buckets are accessible through the web in a normal HTTP request. So you can upload content inside it and make it available to anyone anywhere in this world. Okay, so it uses the same protocol HTTP, which we have already seen previously. So whenever we send a request and the data gets uploaded properly, it gets HTTP 200 request, means the successful processing is done. So it uses a very simple process how normal websites work. So the benefits that you receive from it is basically the data that is stored has a key, which is basically the name of the object. The value is basically the data in the object. So if you are storing an image, the image has a name, and the data or number of bytes that make that image is your value. Version ID here, actually versioning means basically we have something called version control system. In that system, what happens, you store your information in a place, and then when you modify this information, when new information comes up, new versions of information is built, and these previous versions are kept if you need to go back to it. It's actually used in programming, like a version control system, for example, Git. The same thing which is done with Amazon S3. Here, once you upload a file and you do some changes in that file and upload it again, so it will create a newer version of the image of the specific file that you have uploaded. All this information put together is called your metadata. So data about the data. And the last option is the permissions. So as we can see, this is a public cloud component, so things can be available to people. So to make things available to people, you need to specify proper permissions for the specific resources that you're trying to make available for people to access and use it. So consistency is important in case of a cloud service. Like here we think about like this is write service. So once you write down the data, how long it will be available, like how long it will take for the data to be available to the client. It's actually instantly. Once you write down the information, instantly this data is available to me. If you do some changes, if you override the changes, and then it will take some seconds for this data to be propagated, because the thing is that the data is not stored in one single place, it's actually stored in multiple locations. So because it is stored in multiple locations, so the data has to be properly synchronized in all the places, so that's why it takes a few seconds. So this delay is actually not something that you can notice too much. Okay. Next thing is basically availability and durability. So now these two comes into a feature called business continuity. Business continuity in administration basically means that whenever you are providing some data to someone, like the availability of the data and the durability of the data is very important. Availability means like how long the data is available to you. So if you are taking a time frame for 24 hours, so during the 24 hours, how many seconds, I can expect the data not to be available. Okay, so for based on that, you find out a percentage. Okay, durability is like something you provided a data to a service provider. What is the most likely possibility that your data may get lost? So out of some million times, how many times you can lose your data? That is kind of like durability. There are maths behind it. So business continuity maths are there, which is used in system administration to find out these numbers. These are numbers actually calculated from a math. So AWS S3 also provides these specific features. Lifetime management basically, lifecycle management basically means that once you upload an image or once you upload a file, it after some time it becomes like stable. It doesn't change. So you are done with the file. So you don't want to change it anymore. But you don't want to spend money behind it by keeping it inside S3. So what is the solution? You can move it to some other layer of S3. So S3 gives you multiple layer of storages with different price ranges. So the longer you keep the data in some place, the less you need to pay. Okay, so there are multiple layers in which you can put your data, and the costing for the storage of data will decrease. Versioning, as I said previously, also version control system, which actually provides you with multiple versions of the file. If you take one file and upload it and then modify it, upload it again, then it can be versioned to maintain that all the previous versions. Encryption, as you know, is basically a way to protect your data in rest. So data, when it is stored inside a storage system, maybe a hard disk, the data, if you need protection over the data, that will be considered as a data at rest. So it provides you a data at rest encryption. So the data cannot be seen by anyone who's getting access to the hard disk directly. So it needs some keys to like decrypt the data to see or make it available to the client. Multi-factor authentication basically means like only with a password you cannot do certain things. You have multi-factor authentication devices like maybe a smart card or a smart device which can generate some numbers, which numbers can be used when you're deleting something. So it's not like someone can just log in and delete some files. If you want to delete some file, you may need to provide an authentication through a mobile device or something else. Okay. So for the lab, so as we have already seen that we have the program built for us. So we'll just try to upload that program and we'll try to understand how this thing gets deployed in the S3 cloud. So you can see here, so this is the script that was shown to you previously. It was a simple page, which if you opens something like this. It's a simple web page, which has a background. It's a simple page. So our task is to deploy this thing onto our S3 bucket. So what we'll do first, we'll log into the account. So I'm currently logging in. I will show you the screen right away. So if you see, this is the Amazon AWS console. In this console, you can see all the services that you have with Amazon. So Amazon provides you with the compute services. It's providing with storage services. It's providing with the database services. It's providing with network services. It's providing you with analytic services. You have IoT. You have machine learning. You have mobile services. You have a lot of different services which you need. So currently, our concern is about storage services. So we'll be going to Amazon S3. So if you click on this thing, a window like this will appear. This is the S3 management console. Okay, so here what we need to do is to create a new bucket. So we'll click on the create bucket option. It will take us to this place where we need to put a globally unique name for your bucket. So I'm putting here NIID-2000. If this name is available, so when I go outside, it won't show me a message. Otherwise, it will show me that the name is already being taken by someone else. So our bucket name is NIID-2000. The location where it is deployed is actually US East North Virginia region. Okay. So you can deploy it anywhere else, but the charges will be dependent on the location. Okay, so different places have different pricing range. Next thing is that you want to make this thing a public bucket because you want to deploy a website. So websites are publicly accessible. So you want to remove this option or uncheck this option for blocking all access to the public user. So here at the bottom, you get the option to acknowledge, okay. Then you create a bucket. So once the bucket is built, it will show up. So once the bucket is created, it will show here as NIID-2000 bucket. So you can see here is an option called access, which says that objects can be public. That means you have made it public. So we'll click on this thing. So now we are entering the bucket section. So now you can upload the content inside the bucket. So you just have to drag your content from your project. So I'm uploading these 3 files which make up our entire project: the HTML file, the image in the background, and one 404 error file. If something goes wrong, so this should be visible to me. If someone tries to get us inside some page which does not exist, so this page will be displayed. So I'm uploading this thing. So the upload process has started. So as you can see, all the files are uploaded. So the next step is to make all of these files public. So you select all of them, go to make public and make public option to make them available to the client, whoever wants to access it. The next step is that converting this bucket NIID-2000 into a static website. To do that, we need to go to the properties window. From the properties window, we'll go into static web hosting. Inside that, we need to select use this bucket to host website. This is the endpoint or the location from to where you can access this website. So the file that we have inside our bucket, which is actually the main file, we call it the index file, is called the index.html file. And the error file is the 404.html file. Once you have put the index file and the error file, you can save it. So once it is saved, now your bucket is deployed as a static website. How will you access this thing? You need to go to this endpoint. So if someone opens this thing, he will be able to access the site that you have deployed like this. So if you someday buy a domain name, you can just use domain redirection to redirect your traffic to this location, so your site will be available. So it's a very simple process. What we have done, we have just uploaded bucket components and we have made them public, and then we have just changed the properties of the bucket to make it a static website, and this endpoint is now serving me the website that I have built. So guys, thank you for your time. Okay, so this concludes our webinar presentation about web hosting in AWS Cloud. So we have gone through the initial architecture of a web application from the 3-tier design. Then we have learned about HTML, we have seen about CSS, we have learned about JavaScript. Then we try to understand the architecture of a simple single page application like this one. Then we try to understand how cloud computing works. Then we try to understand how the AWS is one of the service providers that we have. Then we try to understand S3 architecture. Then we try to upload a single page application and to deploy it to see as a live application that we have. So thank you for your time. Thank you.